All right, let's continue on with section 6.2 and look at the examples on page 2. Example 2 says use properties of logarithms to write the following as a single logarithm. The procedure we're going to do here is just the opposite of what we did on the previous page. So in example 1 on the previous page, we were asked to expand the following using properties of logs and then simplify. So we took these single logarithmic expressions and then expanded them. We're going to do the opposite in example 2. We're going to take these expanded forms and condense them down to a single logarithm. So let's start here with the first one. I have log base 3 of x minus 1 plus log base 3 of x plus 1. Anytime I add two logarithms that have the same base, I can rewrite it as a product of two logs, a product of those two. So this is going to be log base 3 of the quantity x minus 1 times x plus 1. And I can further simplify that by actually figuring out what this product is, and that looks a lot like it's going to end up to be x squared minus 1. So there you have it, folks. That's the first example there, rewritten as a single logarithm. Okay, I'm going to speed through some more of these, and we'll stop and make a few comments if needed. All right, folks, there you go. That one's all done. And notice that this is the difference of two logarithms that have the same base, so I can write it as a quotient. And x minus 1 over x plus 1, there's nothing I can simplify there. Example C, I have the natural log of x plus 3 times the natural log of y. First thing I'm going to do is rewrite 3 times ln of y as ln of y cubed. Now I have the sum of two natural logs. I can rewrite that as a product. Natural log of x y cubed. All right, part D here. We've got a sum of two logs and then a subtraction of log. They're all base 10, so I'll have the same base. I'm going to start by taking care of these multipliers up front. Folks, hopefully you remember on the previous side when I was talking about these properties of logarithms that you can go either direction with those properties. So here I kind of did the reverse of the power property. Instead of taking an exponent out of the logarithm, I put it back in to turn the 2 times log of y into the log of y squared. And I did the same thing for 3 times log of z. Now I have a sum and a difference of 3 logs here, so this is going to be a combination of the product rule and the quotient rule, and your final answer is going to look like this. Final answer, log of the quantity x times y cubed divided by, x times y squared divided by z cubed. All right, we're cooking with gas here, folks. Let's move on to example E here. I have the natural log of x plus 1/2 times the natural log, 1/2 times the natural log of y minus 1/3 times the natural log of z. Looks very similar to the previous problem, but notice now that I have these rational exponents instead of integer exponents. So let's see what happens here. All right, folks, here you'll notice that I turned 1/2 times the natural log of y into the natural log of the square root of y, because this 1/2 multiplier out front can be moved inside the logarithm as an exponent on y. And we can further simplify this as follows. Final answer, natural log of x times square root of y divided by the cube root of z. All right, let's take a look at example F. And this is the first one that I would say the level of difficulty is ratcheted up quite a bit. So we're going to step through this one just a little bit at a time. First thing I'm going to do is I'm going to rewrite the opposite of the ln of x. I'm going to take this multiplier of -1 and I'm going to move it inside the argument of the exponent or the logarithmic function. So that's going to be the opposite of ln of x. It's the same as the natural log of x to the -1 power. And we'll deal with that -1/2 in a minute. So the ln of x to the negative 1, I can rewrite that as the natural log of 1 over x. And now let's talk about the minus 1/2. So I'm going to write it as minus the ln of something. And let's talk about what that ln of something has to be. So I'm going to work off to the side over here for a second. I need the ln of something to be equal to 1/2. Well, I know that the natural log is base e. So I wonder if there's something I can do with e inside the logarithm to give me an output of 1/2. And I know that the natural log of e is 1. It's not 1/2, but if I put an exponent up here of 1/2, then I could rewrite that as 1/2 times the natural log of e. And the natural log of e is 1, so that would equal 1/2. So that's what I really need to do here. I need to take the ln of e to the 1/2. So I'm going to write e to the 1/2 in here. And hopefully you followed along with that, because that was the trick that was needed. Now I have a difference of 2 logarithms here, so that means I can rewrite that as a quotient. So this is going to be the natural log of 1 over x divided by, well, let's rewrite this e to the 1/2 as the square root of e. And that looks ugly, so we're going to rewrite that even further. And pardon my mess here, but we're going to get rid of this little bit of work we did here. And we're going to rewrite this as the natural log of, well, I have 1 divided by x divided by square root of e, which is the same as 1 divided by x times 1 over the square root of e. So this is going to look like this. 1 over x root e. And that's pretty impressive. That was a tricky one. That's our final answer. Let's see if we can move on and do a similar thing in the next example. Alright folks, so I have the log base 3 of something has to equal 4. If you remember the conversation we had in the previous lesson, we can rewrite any logarithm as an exponential. And this can be rewritten as 3 to the 4th equals question mark. And 3 to the 4th power, let's see, that's 3 times 3, which is 9, times 3, which is 27, times 3 again, which is 81. So that means our question mark is no longer a question mark. It's now 81. And there's our final answer. We have the log base 3 of 81 times x. I wish I could say it was going to get easier, folks, but example H and I are pretty tricky. So this one we have log base 2 of 2x plus log base 1/2 of x plus 1, and this is a problem. Take a look here at the 2 bases we have. We have a base of 2 and a base of 1/2. So the properties of logarithms we learned on the previous page, the product, quotient, and power rule, those only work if the product and quotient rule specifically only work if you have the same base. So what we're going to have to do here is get the same base. And we have a choice. We can go to a base of 1/2 or a base of 2. But either way we do that, we're going to require a change of base formula. So I'm going to go ahead and change everything to base 2. And the first part, log base 2 of 2x, will look the same. But now for the log base 1/2 of x plus 1, I need to use a change of base formula. And if you go back to the previous page, you'll see that to change this to base 2, I'm going to do the log base 2 of the argument to the function, x plus 1, divided by log base 2 of the base of the function, 1/2. Okay, so that's my change of base formula to change this expression, log base 1/2 of x plus 1, to log base 2. So now it's log base 2, but notice log base 2 of 1/2, there's no variables in there. That's just a constant. So we need to figure out what that is. Well, let's see, 1/2 is 2 to the negative 1 power. So I think the log base 2 of 1/2 is equal to the log base 2 of 2 to the negative 1, which equals the opposite of log base 2 of 2. And folks, the log base 2 of 2, oh, I lost part of my L there. The log base 2 of 2 is 1. So this whole thing here simplifies to negative 1. So my whole denominator there is going to simplify to negative 1. And okay, now I'm happy because that's all blue now that you can see that. That was a little side note there for you. So let's see what we get when we substitute in negative 1 there for my denominator. I have log base 2 of 2x plus log base 2 of the quantity x plus 1 divided by negative 1. Well, that becomes log base 2 of 2x minus log base 2 of x plus 1. And that's a difference of two logarithms on the same base, so I can rewrite it as a quotient. And this will simplify to the log base 2 of the quantity 2x divided by x plus 1. And folks, that one is not trivial. That was not easy. So you might need to pause this one, take a quick breather, maybe even, I don't know, go down and get yourself a protein bar or something and recharge. But that was tricky. We're going to do the same type of idea on the next one. So I'm going to speed through this one. Hopefully you can keep up. All right, folks, I'm a victim of my own poor planning here. I've kind of run out of space. So through the magic of modern technology, I can create more white real estate for me to finish this problem off. I now have everything written in terms of base 3. I have the log base 3 of x plus 1/2 times the log base 3 of x minus 1. I can write this as a product of two logs, but also remember I can take this exponent of 1/2, move it inside the argument of the logarithm, and it ends up looking like this. I have the log base 3 of x, that's from here, times the square root of x minus 1. Holy cow, where did that come from? Well, don't forget that if I raise x minus 1 to the 1/2 power, that's like the square root of the quantity x minus 1. So there is my final answer for question 2, part I. All right. Hopefully you're not too damaged from these examples. We can move on to example 3. Example 3 says use an appropriate change of base formula to convert the following expressions to one with the indicated base. Well, we've already done a little bit of this work in the previous example. We had to convert log base 1/2 to log base 2 and log base 9 to log base 3. But I want to take a quick pause here and take a trip down memory lane to show you old school calculator stuff. So here's my friend, the TI Inspire CAS calculator, but I'm going to show you how we had to change base back in the day. So let's say I wanted to know the log base 2 of, well, let's just pick 16. I mean, this is one that we know. Okay, it's 4. Well, how did we have to do it back in the day? We didn't have a log base key, folks. We were chiseling our math homework in stone. We certainly didn't have a log base key. But we did have a scientific calculator that had a plain old base 10 logarithm. So a plain old base 10 logarithm I could use to determine what the log base 2 of 16 was. And if you recall, the change of base formula that I showed you for log base 10 was just log base 10 of the input divided by log base 10 of whatever the old base was. And when I do that, I get 4, same result I had before. So that's how we had to do it back in the day. Hopefully you notice when I entered these into my calculator, I left out the 10, but the calculator knows that if you omit the 10, that it defaults in as the common logarithm by, I guess that would be by default. Okay, so enough about old calculators. Let's go back here and convert 3 squared to base 10. Well, if I want to convert that to base 10, I look back at my change of base formula, and if I turn a to the x into base 10, it's going to be a to the x equals 10 raised to the x times the log base 10 of a. So for this one, 3 squared to base 10 is going to be 10 raised to the 2 times the log base 10 of 3. And that's it. That's it, folks. I'm going to go ahead and rip through the rest of these. If any of them are noteworthy, I will make mention of it. In fact, maybe it would be helpful if I wrote those change of base formulas over here for you. So that's how we change base from a to b of an exponential. And here's how we change base from a to b of a logarithm. Okay, and you can find those formulas on the front side of the paper as well. On to part B. That's it, folks. We're done with section 6.2. Good luck on WebAssign.